Hi guys. So today we're going to look at regression and different models of exponential functions. So to start, we're just going to look at a couple of tables and determine what type of relationship these values have. And you may have seen a few of these back in Algebra 1, but what we're going to do first of all is look at how these values are changing. So on all of these charts, you'll notice these x values are changing by a constant amount. Okay, it's a different number each time, but each time our x values are constant, are changing by a constant amount. So what we're going to look at then is just how our y values are changing. So if you look at this first chart, this is multiplying by 2 every single time. So since our x's are changing in a constant way and our y's are changing by multiplying by a constant number, that's how we know that this is an exponential model. All right, because it has a common ratio. All right, but now let's go ahead and look at C. Again, the x's are changing by a constant amount, so we look at how these are changing, and these I'm subtracting 3 each time. So this actually is a linear model because we are subtracting the same number each time. So if you're adding or subtracting a common number, then it's going to be linear. If you are multiplying or dividing by a constant number, then that's going to be exponential. That's going to be pretty important for you guys later on once you get into pre-cal and you start looking at sequences and series. So you're going to learn about something called a geometric sequence or a geometric series, and that is the one that's going to look like your exponential functions. Linear, you may have already seen these arithmetic sequences back in Algebra 1, but those are what this linear model is going to represent. Okay, but for what we're doing in here, we're just going to look at the fact that these are exponential or linear or quadratic models. All right, so now let's look at B. Again, my x's are changing by a constant amount, but let's look at what our y's are doing. Okay, so nothing consistent on adding, and then again, this one's getting smaller, so I'm multiplying. I can't multiply by anything to get from 0 to 2. Here I'd be multiplying by 4, then I'm not. So the multiplication is not going to work either. So what we can check then is our second differences. So instead now I'm going to look at the change from -2 to 2. So I'm looking at the change at this second level, and those are consistent. So if the second differences are constant, then that's showing a quadratic model. Okay, so this is a quadratic set of data. And then finally looking at D, again, x's are consistent, but I am dividing by 3 or multiplying by 1/3 each time. So this is also an exponential because it has that common ratio of 1/3. All right, so next thing we're going to look at is just writing a function, if an exponential function that goes through a set of points. So you were able to do this with a lot of different functions that you've done. We can also do this with exponential, and the easiest way to do this is just using a system of equations. So I'm going to use the form y equals ab to the x, and I'm just going to substitute my x and my y. So I'm going to get 6 equals ab to the first. Then I'm going to have, so we're going to have a second equation. So I'm going to do 54 equals ab to the third. So in order to solve for this, then I am going to I'm going to solve for a in that first equation. So to get a by itself, I would divide. So that's 6 over b. Then I'm going to replace a with that value. So I have 54 equals 6 over b times b cubed. And if I have b cubed divided by b, I can subtract those exponents. So I get 6 times b squared. And now to solve for b, I would just divide. And then I can square root. So I get that b is equal to 3. Once I know what b is, I can substitute that back into my original to solve for a. So I get that a is equal to 2. And now I can find that my equation would be 3 times, whoops, other way around, sorry about that, 2 times 3 to the x. All right. On B, I actually want to change that example so you guys can see one that doesn't start off at 1. So the example that's online, I changed it to 2 and 5 and 3, 15. Okay, so we're going to work this out the same way. I'm going to set up two equations. So y equals, 5 is replacing y, equals ab to the second. My second equation is going to be 15 equals ab to the third. So I'm going to get a by itself in that first equation. So a is equal to 5 divided by b squared. Then I'm going to replace a. So 15 is equal to 5 over b squared. That is times b to the third. Okay. If you're doing b to the third divided by b squared, you'd be left with just b. Divide both sides by 5, and I get the value of b. Then I substitute that back in order to get my a value. So 5 is equal to a times 3 squared. So a is going to equal 5 over 9. So then my equation would be y equals 5 over 9 times 3 to the x. So in this model, my initial value would be 5 over 9, and my rate here would be 3. This would be showing exponential growth. All right, so the last thing we're going to look at is regression. So you've probably done regression before in previous classes with linear regression, maybe quadratic regression. So we're going to look at exponential regression here. Okay, so we have a store that's selling trampolines. There's a table of data here, and we're going to use that data to come up with an exponential function to model it. Okay, so what we're going to do, the steps for your regression are on here. So we are going to go ahead and go to menu. We're going to go to statistics. You're going to type your x values into list 1 and your y values into list 2. Okay, so list 1 is the x's, list 2 is the y's. Once that's done, okay, let me go back a few steps so we can see what it looks like. You have two options. Okay, one option is you can see what the graph looks like. Okay, and this is a good idea if you don't know what type of regression you have. Okay, so I'm going to go ahead and look at my graph. I'm going to graph 1. Okay, and now you can see the way this is going. Okay, you can see that your data tends to be going up this way. Okay, so we know it's not linear. It could be quadratic, it could be exponential. So figuring out which of those it's going to be is going to depend a lot on your problem. Now this one specifically wants us to find exponential data, so we're going to find that. But keep in mind of what makes sense for your problem, and we'll talk about that more here in a second. So to actually find this regression, at this point we're going to do calc. And then since I want exponential regression, okay, I don't see that as an option right now, so I'm going to click F6 so I can see more options. And then on there you'll see exponential. Okay, so there's my exponential option under F3. And then I can see that this is, I can use either version. I can use a base of E, or I can determine what the base is. So I'm going to go ahead and do F2, AB to the X, because that's what we're used to seeing. And there's my value. Now that R squared value, okay, the closer that R squared value is to 1, the better your model is. This is pretty close, 0.997. That's a pretty good regression model. Right? A is just going to replace your A, B is going to replace your B, so your equation here would be y equals 8.46 times 1.42 to the x. All right. Then if you want to use this equation, you can. If you select copy, it won't actually enter it in there automatically. Mine did because I have done it previously. So you'll need to press enter and then press enter again to be able to actually see it. Okay. Now another option here is to do regression from the very beginning. Okay. So I'm going to go ahead and just look at my data. You also could have done regression from this point. So you had the option here to do calc. Okay, so from there, then you would go ahead and do F2. And this is a good idea if you already know what type of regression you're doing. Okay, so calc, and then I would do reg F3, which is regression. And again, same thing, I'm going to find the type of regression that best fits my model, which in this case is exponential, a times b to the x, and I still get that same value. All right, now the last thing on here is just asking, do you think this model can be used to predict the number of trampolines sold in the 15th year? So in this case, it may not make a lot of sense because think about how quickly this is growing. And if I actually plug in that value, so I'm going to go ahead and look at my graph. Okay. Sorry about that. All right, sorry about that. There we go. Okay, so there's my model. I'm going to make my window a little bit bigger so I can see 15 years. So I'm going to go up and make this 20. All right, so look at how fast that stuff is growing. I can't even see right now, so I'm going to go to make my Y max even bigger, just so you can see how big some of these values are going to be here. Okay, so look, and because it's growing at that fast of a speed, it probably isn't reasonable for this problem that those sales are going to continue to just go through the roof. Eventually, they'll probably start to calm down, which is why exponential may not be the best choice here. Okay, but again, there will be some models where exponential will make the most sense, like a lot of the word problems we've looked at so far. All right, so again, your steps for regression are on here. If you need to view the graph to see your scatter plot, you can, or you can just go straight to your exponential regression.